You have watched ice float in a glass roughly 10,000 times, and it has never once bothered you. That is the problem. Because if you take a lump of solid iron and drop it into molten iron, it sinks. Solid lead sinks in liquid lead. Solid mercury, solid copper, solid nitrogen. All of them sink in their own liquid because cold packs things tighter. That is how matter behaves. And then water arrives at the same fork and does the opposite, and you have accepted it without a flicker of suspicion, the way you accept the ceiling. Ice should sink. It does not, and I want you to tell me why. I already know what you are going to say. Air bubbles. Ice traps air. Air is light, so ice floats. Wrong. Take a block of laboratory ice, degassed, frozen slowly, clear as window glass with not one bubble in it, and it floats exactly as well as the cloudy cube from your freezer. The bubbles are why your ice looks white. They have nothing to do with why it floats. Second answer, the one people reach for when the first one dies. Ice is lighter than water. That is not an explanation. That is the question wearing a lab coat. Yes, ice is less dense. I asked you why. Third answer, the one you got in school, the one that sounds clever enough to survive a dinner party. Hydrogen bonds. Water molecules grab each other. The bonds get stronger when it is cold, and the thing puffs up. Closer, and still wrong in the one place it matters, because bond strength is not what makes ice float. Sit with that, because the entire video turns on it. Here is the water molecule. One oxygen, two hydrogens, bent at about 104.5 degrees. Not a straight line, bent. And on the far side of that oxygen sit two lone pairs of electrons, invisible in every cartoon you were shown, and they are the entire story. Those two hydrogens and those two lone pairs shove each other apart into four directions. And those four directions point at the corners of a tetrahedron, a pyramid with a triangular base. Every molecule in ice is locked to exactly four neighbors, and it does not get to choose where they sit. The geometry chooses. Now build a solid out of that rule. You do not get a tidy stack. You get a scaffolding of six-sided rings holding each other at arm's length, with hexagonal channels running straight through. Empty space. Actual, deliberate, load-bearing empty space. And that same six-sided rule is why every snowflake has 6 arms. Feynman put this in the very first lecture he ever gave at Caltech, and he did not decorate it. The crystal pattern of ice, he said, has many holes in it. When the organization breaks down, these holes can be occupied by molecules. Read that again. Ice does not float because it is puffed up with something. Ice floats because it is built around nothing. So melting is not the gentle loosening you picture. Melting is a demolition. Heat the lattice until the molecules shake themselves out of position. The scaffolding buckles, and the neighbors fall inward into the holes that were holding them apart. The liquid is the wreckage, and wreckage always packs tighter than architecture. Now the numbers, because this is the point where it stops being a story and starts being physics. Liquid water at 0 degrees comes in at 0.9998 grams per cubic centimeter. Ice at 0 degrees, 0.9167. Same molecules, same temperature, and the solid has handed over about 9% of its density to hold empty rooms open. A kilogram of water fills 1,000 cubic centimeters. Freeze that same kilogram, and it now demands 1,090. And the bond doing all of this? A hydrogen bond in water runs around 23 kilojoules per mole. The covalent bond holding that oxygen to its own hydrogen is about 463. So the bond that lifts every iceberg on this planet is roughly 1/20th the strength of the bond sitting next to it. It never won by force. It won by insisting on an angle. Which brings us to the part where I take something away from you. You have been told, probably more than once, that water is the only substance on Earth that expands when it freezes. Unique, miraculous, a one-off in the entire periodic table. That is not true, and it never was. Silicon expands when it freezes. So does germanium, for precisely the reason ice does. Because they build tetrahedral, directional, wide-open networks, and then collapse into denser liquids. Gallium expands, and so do bismuth, antimony, plutonium, cerium, and acetic acid. In that same lecture, Feynman names water and type metal in the same breath. Type metal is the lead and antimony alloy printers used for centuries, prized because it swells as it sets and shoves itself into every corner of the mold. Every book printed before photographic typesetting exists because a metal did the same rude thing your ice cube does. So water is not a miracle. Water is a member of a family. And if that lands like a demotion, stay with me, because the family is stranger than the miracle ever was. Now watch what that geometry does once you let it out of the laboratory. A lake in December. The surface cools, gets denser, sinks, warmer water rises to be cooled in its turn, and that churn keeps going until the whole lake reaches about 4 degrees. 4 degrees is where water is at its densest. Below that, the cooling water starts getting lighter again, so it stays on top, and that is where it freezes. The ice sits on the roof and it insulates. Underneath it, liquid water at 4 degrees, and inside that water, everything that has to stay alive until March. If the lattice packed itself tight, that ice would sink, and the lake would freeze from the floor upward with nothing to slow it. If you want more physics that takes your comfortable answers apart, subscribe. That is the whole pitch. An iceberg shows you the arithmetic in public. Ice sits at 0.917, seawater at roughly 1.025. Divide one by the other and you get 0.895. So an iceberg floats with 89.5% of itself underwater and about 10% in the air. That is not a figure of speech, that is a ratio. And when that same 9% happens inside a sealed pipe in January, the ice has nowhere to go. The pressure climbs toward 30,000 pounds per square inch, and copper splits like wet paper. Your plumbing is destroyed every winter, and mountains are quietly taken apart every spring by a bond 1/20th the strength of the one beside it. And since we are being rigorous, let me take a second thing away from you. This one might be mine. You have heard that a skater glides because the pressure of the blade melts the ice into a film of water underneath. It is a lovely story. Pressure genuinely does lower water's melting point. Squeezing this stuff makes it melt rather than freeze, which is the phase diagram admitting the solid is the bloated one. But run the numbers. You need roughly 138 atmospheres to shift the melting point by 1 single degree. A skater is nowhere close. Bowden and Hughes settled this in alpine ice caves in the 1930s, at temperatures that never climbed above -3, and the skis still slid. The real answer is that ice carries a thin, half-liquid layer on its own surface without any help from you, plus the heat your friction generates. Physicists are still arguing about the proportions. Which brings me to the claim you will hear in almost every other video on this subject, that if ice sank, life on Earth would be impossible. Be careful with that one. Floating ice really is why cold lakes and cold seas stay habitable, and a world without it would be emptier in ways that are hard to overstate. But the tropics never freeze. Salt water holds out until about -2. Pressure lowers the melting point at depth, and geothermal heat keeps arriving from below. And during the cryogenian glaciations, when this planet came as close to a frozen shell as it ever has, life did not go out. Philip Ball, who has written about water more carefully than almost anyone, warns against handing it some mystical, life-giving agency. Water is not fine-tuned for you. You are fine-tuned for water. So here is what you actually have now, with the easy answers cleared off the table. Not a miracle liquid, a molecule with a bend in it and two invisible pairs of electrons, obeying one stubborn rule about angles. And that one rule builds a crystal with rooms inside it, floats a continent of ice across the North Atlantic, keeps a carp breathing under a frozen pond, splits your pipes open in January, and printed every book you have ever held. You did not lose anything today. You traded a fact you never questioned for a mechanism you can actually see. Feynman had a friend, an artist, who told him that a scientist takes a flower apart and makes it dull. Feynman thought that was nutty. He could see everything the artist saw, and then the cells and the processes and the whole machinery running underneath it. The science knowledge, he said, only adds to the excitement and the mystery and the awe of a flower. It only adds. I do not understand how it subtracts. So go and look at the ice in your glass. It is a scaffold of hexagons, holding itself open against gravity because of an angle of 104.5 degrees. That is not mysterious. That is magnificent. Subscribe, and I will come for another one of your comfortable answers. You have one about why the ocean is blue. It is also wrong.